Hello everyone, thanks for watching my video today. In this video, we're going to talk a little bit more about probability and a couple more vocabulary words that we'll need to know. Starting with mutually exclusive. What does that mean? It means two events are mutually exclusive if they do not share any outcomes. For example, we have two examples here. One, drawing a 5 versus drawing a 7, and drawing an ace versus drawing a black card. All right, so if you think about this for a second, in the first example, there's 4 5s, right? There's a 5 of hearts. So let's go 5 of hearts. There's a 5 of diamonds. There's a 5 of clubs. Sorry for a bad club there. And there's a 5 of spades. Okay. Same thing for the 7s. Okay, except there are the 7s of those suits. But there's no cards that are 5s and 7s, right? On the other hand, with aces versus black cards. So there are 26 black cards, right? 13 clubs, 13 spades, and there are 4 aces. However, 2 of those aces are black. So the ace of clubs and the ace of spades would fit into both of those. While the ace of hearts would be over here, and the ace of diamonds would be over here, and the other 24 other black cards, which I'm not going to go into drawing all of those, would be over there. Okay, so the first events are exclusive. You can't draw a 5 and a 7 in one card. All right, the second events are not exclusive because we could draw an ace that's also black. All right, so some notation here. P of A, we've already talked about that. That represents the probability of event A happening. So we write P of whatever that event is. But a couple other new symbols here. An upside down U, we have not seen that yet this year. That represents the probability of events A and B happening at the same time. While this U, which we already know that means union, represents the probability of events A or B happening. So just to remind you that this means here, this means union. This on here, this is new, this means intersection. But basically for what we need, this means and, this means or. All right, so the first example there, the two events that are mutually exclusive, so the intersection of A and B would be the empty set 0. It's impossible to draw a 5 and a 7 at the same time. All right, so find the probability of these events. If A and B are events in the same sample space, the probability of A or B occurring would be to find probability of A, add the probability of B, and subtract the probability of A and B happening. If they're mutually exclusive, to find the probability of A or B, you just do probability of A plus probability of B. And you don't subtract this because it can't happen, because they're not mutually exclusive. They actually are mutually exclusive, sorry. So let's take a look at a couple examples here. First, if I'm going to select one card from a standard deck of playing cards, what's the probability it's red and a face? All right, so we're going to go probability of red and face. All right. Now the better way of writing that would be probability of red and face, like that. Probability of red intersection face. All right. So if we just think about this, there are 12 face cards in the deck, right? 4 jacks, 4 queens, 4 kings. And 6 of them are red and 6 of them are black. So the probability of red and face would just simply be 6. And out of how many cards in the deck, that would be 52. So the probability of it being a red face card would be 6 out of 52, or approximately 11.54%. Well, the probability the card is either red or face. So now it's probability red or face. Okay, and that would be written like this, probability of red union face. All right, so to do that, we're going to do the probability of red plus probability of face minus the probability of a red face card. Okay, so probably of red, well, that's going to be half of them, right? So that's going to be 26 out of 52. Probably a face, we already talked about that. There's 12 of them, so that'd be 12 out of 52. And the red face cards, we just figured that out. That's 6 out of 52, so we're going to subtract 6 out of 52. So that'd be 26 plus 12, 38, minus 6 is 32, so it'd be 32 out of 52, or 16 out of 26, or 8 out of 13, which is 61.54%. And number 2, a standard six-sided dice is rolled. What is the probability the dice will come up as an even number or a multiple of 3? So we want the probability of even or a multiple of 3. So the probability of even plus the probability of a multiple of 3 minus the probability of even and a multiple of 3. So probability of even, well, that's going to be half of them, so it's 3 out of 6. Multiple of 3, well, it's 3 or 6, so it's 2 of them, so 2 out of 6. Even and a multiple of 3, that's just 6, so that's 1, so it's 1 out of 6. So we get 3 plus 2 minus 1, which is 4 out of 6, or 66.67%. Okay, the rest of this is just going to be a mixed bag of practice for all the things we've been doing lately. So at this point, you can pause this video, or actually stop the video, and try the rest of it, and the answers will be posted to Schoology later on. Thanks as always for watching my video today. We'll see you again soon.